In this tutorial, I'm going to show you how to use SolidWorks Simulation to analyze a basic part. So the first thing we're going to do is we'll go ahead and create a new part. So new part, okay. And let's take a look here at our problem description. So our model should be 1 inch by 2 inch by 1/8 of an inch thick square, and we're going to have a 100-pound force acting on 0.2 inches at the middle of the beam, and we're going to have it cantilevered on either side, so it's fixed on either side. There's our basic model. Let's go ahead and draw the part. So I'm going to use my front plane here, so right click on the front plane, sketch, and the rectangle, and I'm going to do a corner rectangle. There's some reasons why, but for now that should get us started here. And let's do a dimension, so smart dimension, 2 inches by 1 inch, and we can exit the sketch, extrude 0.125 for the depth of the extrude, and accept our part. Now this will be okay. The problem with this is that there's no place for me to apply my loads. So I really would like there to be some kind of line or marker so that when I go into simulations I can apply it at that 0.2 inches. Alright, so let me go back in and change this. So I'm going to edit the sketch, and instead of going the whole 2 inches, let's see. We want just the left half, so that would be 2 minus 0.2 divided by 2. So looks like I've got something wrong. Try again. 2 minus 0.2 divided by 2. There we go, 0.9. Exit the sketch. And now from here I'm going to make a new surface here, so a new sketch here. I've got my settings set so that it brings it normal. If not, I would have right clicked here and clicked on the normal 2 button so I can look straight on it. I'm going to select the face so everything highlights and click Convert Entity. The reason for using the Convert Entities is it projects a rectangle on here without me having to draw it and places it within place constraints. So I'm inside the sketch. Let's go ahead and exit the sketch now. We'll do extrude, and I'm going to choose that sketch we just created, and I'll rotate it around so I can see what's going on. This is the part where we're applying the force, so it's 0.2, and check, and then repeat one more time. Oops. Let me go back into that feature. Notice this didn't help, there's not a clean line, so I'm going to go back into that feature, edit feature, and I'm going to uncheck merge result. And what that's going to do when I click the check mark is it actually leaves a line. There's an infinitesimally small break between the parts right here. They're now 2 separate bodies. And when we do put this in the forces in the simulation, this will help us. So repeat one more time. So create a new sketch, convert entities, exit sketch, extrude. This was 0.9. Now I have my 2 inches and I'm ready to go into simulation. And I didn't do it again, so this is important. Edit feature, don't merge the result. SolidWorks add-ins, turn on simulation. Now that simulation is on, before I actually start it, I'm going to go ahead and assign materials. So right click on materials and edit material. It comes up thinking that I probably want steel, so I'm going to go into the aluminums. And we're going to choose 6061 alloy. That's just the default 6061 material. So apply that and close. And you can see it's got a little bit of different display now, kind of a little bit darker. Okay. Since I've turned on my SolidWorks add-on simulation, there's now a simulation tab. And if I go there, let's drop down from the study advisor. We're going to do a new study. This is a static study, so click the check mark. And within the static study now, we are going to assign materials. So take all of these 3 I'm going to check to make sure that the material is correct. It does have it as the 6061 alloy. So I'll click apply and close. For the connections, this defines how things happen at these merged points. The default is set up that they're bonded together, the global contact bonded, so we're going to leave the defaults alone. Now we need to add our boundary conditions. A fixed geometry is what we want, and I want this face here and this face here to be fixed. There's some different options. There's fixed, there's a roller, there's a hinge, but we want this to be completely fixed, and it shows a picture of what that looks like. So we'll check that for the fixture. So we've now got our boundary conditions set. For external loads, right click on external loads, and we're going to apply a force. And again, we can apply forces to faces, and since we did that unchecked the merged, so we have separate bodies, we can apply a force right here. I'm going to change it from SI units to English units, and this should be 100 pounds. And it's showing it down. If it was the wrong direction, I would just flip the arrow but this is the correct direction for what the problem statement said. So there's our force. And then I'll right click on the mesh, and we can do create mesh. There's a controller for density, so you can change your density. I'll leave that to you within the project to decide what density you would like the mesh to be. For now, I'm just going to go ahead and run the mesh so we can see what it looks like. And then we can run the analysis. So this is what it looks like. This is on von Mises. If I don't like the units, and I recommend changing everything to English units if it's an English problem, we'll right click on the stress, change the settings, and actually it's the definition, so I'm going to go to the definition tab and change it from Newton meter to KSI. Click the check, and it rescales the values. So 4.2 KSI is the stress that's happening right here. If I go to the displacement, this shows how it's deforming. And again, this is in millimeters, so I'm going to change that. So this is edit definition. That'll take me to that tab directly. Change it from millimeters. Let's put it in mil, which is 1/1000th of an inch. And 0.2 mil is how much it's deforming here. And then if I want to do factors of safety, if I right click on the results, and let's define a factor of safety plot, and we'll do automatic. Aluminum is a ductile material, so most likely the best criteria for failure is going to be a maximum von Mises stress, but we'll let SolidWorks decide what that ought to look like. And we'll click check mark, run that, and so we can see that the factor of safety is about 1.8, with a couple places that are very safe. So these would be good indications of areas that I could think about removing material. Notice this has a factor of safety of 870. If I don't like the scale, maybe I'm more interested in the gradient, so I'm more interested in the stuff that's happening in the red. If I right click on factor of safety, and now we can go into the settings. We'll do chart options, and here is the location of the key over here on the side, and here's its scale. So it's going to go from 1.8 on the small side to 870 on the large side. If I want to see a little bit more refined looking, I can change this to be defined, and I don't really care about factors of safety above, let's say above 15. So what I care about is a factor of safety between 1.87 and 15. So we'll click the check mark, and that shows rescales and lumps everything in this blue category that's way over 15. So this shows me that if I was thinking about removing material, this right here, this area right here, would be good material to lose. So this gives me some advice on where to take material away from the part. So a couple things for generating a weight function from all this. So I'll click the check mark, and now it's a fourth a fourth graph. A couple things that I could do. I can always go to Evaluate and click on Mass Properties, and within the Mass Properties, let's see, it says it's 0.02 pounds. It's probably not refined enough, so I'm going to go into Options and use Custom Settings and change the decimal places. Let's put 6 decimal places. That lets me have a more accurate analysis of the pounds. So this is the weight that the current bar weighs, and so I can take this number and the factor of safety and the total displacement and use all of those to start creating a weight function. So I would go back to my model, maybe change something. Let's just add a hole here, and I'm not going to fully dimension it just for time's sake, and we'll create a feature, extruded cut, extruded all the way through. So there's a hole in my part. Go back to my static study, and you'll notice there is an error next to the mesh. I'm going to right click on the mesh, and this time I'll just use the settings I already did. So mesh and run, we'll go ahead and go through both steps. Now I have new deformations, so there's the stresses again, there's the factors of safety again, and the displacement. So I can compare numbers that I got with different trials together and figure out which is my best option.